Hey there, I'm Taz Singh, and I've been working with communities for as long as I can remember. Fundamentally, communities are made up of people, so this is my journey going to those communities and talking to those people. Come along with me. Oh, amazing. I'm here today with my good friend Phil Pluckthun. Pluckthun? Phil Pluckthun. And he's my good friend from London. And so I thought I'd invite him over and bring him in with the allure of bagels. And so as you can see here, we have a few bagels in this bag. It is nothing nefarious in this very innocent paper brown bag. It is definitely bagels in here.
That's what they say about brown bags, yeah.
And then we went to Melo's for coffee. And so Melo's is this really nice little coffee place around the corner. I don't think Phil's ever been there either. So basically what I did was I kind of tricked him into coming to visit me for bagels and coffee. I told him bagels and coffee takes about 2 hours. And so here he is now. He's captive inside my house with my cat. And so hopefully one, tries to figure out a good way to live with the other. And there's only harmony inside this household because, you can't have anything else when you have a cat and a Phil in your house.
I thought it was safe. You have no basement. So.
That's right. I do not have a basement that he knows about. That is correct. That is correct. Yeah.
My bad.
But no, how are you? How are things? So you obviously just got back from an offsite last week. How was that?
Trip from Barcelona.
Yeah.
It's a lot sunnier than here. And it's just not cloudy. It's not particularly much warmer than here. So it could be 5 degrees and you'd still feel warm. Don't have that in a lot of places around the world. Even when you go closer to the equator, you have that humid warmth next to the ocean often. You still have that kind of a cloudy warmth, but Barcelona is interesting. I don't think I've ever been to a place that can be cold and hot at the same time.
So like this is how you know that he's German, because he has a few different levels of warmth. For me, I'm just it's hot or it's cold, you know what I mean? And that's basically it.
But for me, it's cold and hot at the same time in different ways. Yes.
Cold and hot in different ways at the same time on different metrics, all analyzed and measured differently based on geopolitical situations as it pertains to the locale.
I'm sure German must have invented felt-like temperature.
Oh, I love it. So that sounds like an interesting time in Barcelona. What do you guys get up to? Anything? I think I saw some lovely hot tub pictures on Twitter.
Hot tubs were, if you go to a nice place, you better have some kind of bathing bath or ocean plan.
So what? It wasn't like mild warm enough. You needed to make it humid warm on top of that with a hot tub.
40 degrees Celsius. Yes.
Oh.
Yes.
Oh. So you went from a nice pleasant Barcelona 5 to like a very unpleasant, humid 40. And if I'm not mistaken, you also had your CEO in there.
Yeah, of course.
Yeah, of course. So
that's how you do
it. Is that how business working? Networking works these days? Is you just get in the hot tub with your CEO?
Yeah, of course. As long as you're comfortable.
Well,
if you're not, then I guess you're bad old luck. But
well. I don't know what to say to that, but yeah.
I didn't tell him I wasn't sweating because of the hot tub. Yeah.
Oh God, no. And now I don't know whether to endorse him on LinkedIn or not. Do I endorse him for hot tubbing on LinkedIn? I don't know. It sounds like a new Twitch channel, like Phil in the hot tub.
We did think about setting up a hot tub stream. I mean, that kind of business niche cannot be ignored. We are a tech company, but that makes us very good at streaming, right? Twitch streaming specifically, yes.
Oh no. I feel like we're starting off with a very downhill trend on this chat right now. So we're gonna bring it back. We're gonna roll it backwards and kind of go uphill from here, hopefully. So, Phil, tell me more about what you do. What you're working with good friend Yovi, good friend Andy. Obviously, the founders there, good friends as well. Max in particular, I know Max. I haven't met Tim yet, funny enough, but love to meet Tim one day. I don't think I know anyone else on your team, but essentially, what are you up to over there? What sort of things that you work on? What are the things that excite you?
Mm-hmm. Well, Tim is ex-Prisma, and Max has worked at Spectrum, and one of them has worked on GraphQL tooling. The other person's worked in a company that's built on GraphQL and with GraphQL. And specifically, the company's just built to address the needs that they found when they were building with that, and also the needs that we've seen as employees before we joined GraphCDN. So we kind of just built a company around GraphQL tooling because we believe there are specific needs that are unmet. And the first thing to start with was GraphCDN, a CDN network for caching. So what we just get up to is really just, and that's kind of the purpose of the offsites, have enough time to not only work on us as a team and company, but also work on new ideas of what we can address after.
That makes sense. And I'm not going to ask you about those new ideas because I'm sure
secret.
it is top secret, as he said. It's locked in that imaginary basement that I don't have, that I haven't told him about. And so we're not gonna like basically dust off the covers on that one just yet. But in terms of the stuff that you've been up to, like essentially I've known you from before, where you worked on Urkel and worked on GraphCache in particular, which is like a normalized client-side front-end cache for GraphQL. Is basically GraphCDN on the back end like similar to that kind of approach on the front end? Like how does it differ?
Well, the things we discussed was doing more of what is being done with Urkel, doing more what is being done with open source tooling on the back end. Obviously, coming into GraphQL on the back end, it's a very crowded space, but there are still a lot of unanswered questions around how teams operate GraphQL APIs. And specifically what we recognized is that while we were solving specific problems with GraphQL, what people are actually interested in is having a partner that understands GraphQL on the backend and helps them operate these APIs.
Right.
So similarly, if you were to compare that to a GraphQL client, a lot of people come into that community and they just ask questions around how should I build my API? How should I use GraphQL? And how can I build my app? And for an open source project, maybe not the best questions to ask right then and there. But as a company, those are indicators that basically there's a lot of need around having people that can kind of guide you down a set path.
And I think that's probably one of the essentially one of the best things about GraphCDN, in my opinion, is that it's kind of like a very simple setup. It's basically a matter of just adding a DNS like for GraphCDN, or is that already done for you even?
Well, the DNS is already done for us.
So you basically just point your site at GraphCDN, tell GraphCDN to read from like your prior GraphQL API, and you're basically done.
You're basically done. The idea
you get
is that you don't have to do a lot to get it running there.
And then you get like all the advantages of like a fast, like I guess long-lived cache that's distributed around the world. Like all of these lovely, great things that GraphCDN offers. I think also you also offer usage analytics on kind of query parameters not query parameters, like the operations of which your client is making to that server. So you get all of these things just by basically changing two URLs, changing one URL on your client to point to GraphCDN, changing GraphCDN to look at your GraphQL API. You basically get all this stuff for free. Well, not for free, but you get it all. You get it all pretty easily.
Yeah, the idea is basically once you're operating a GraphQL API and once you actually have it out there, making that cheaper, more efficient, and you knowing hey, this is actually how the API is used is pretty crucial. Because as your team grows, you kind of start to lose track of, hey, these are the fields that are actually used. These are the things that we have to keep an eye on. These are the things that are unused. And that's kind of what we're exploring right now. Building that and making better. Apart from the things that I won't talk about, which are the things around how we can build APIs and how we can make it easier to build APIs themselves.
Interesting, very interesting. Well, I'm not going to pull any sort of confidential information out of Phil, but I'd highly recommend if you do have a GraphQL API and you are looking to make it more performant, these are the guys that know how to do it. That's literally their job. And so if anyone knows how to do it, I would trust the people like Phil, like Yovi, like Andy, like Max, like Tim. Like my cat back there that is doing things and I can't help but check in on her. But I trust these types of people where it's literally their job to make your GraphQL APIs fast. And I think, again, the thing that's always impressed me is just how easy it is to do. It's just simply changing your client-side URL to point to GraphCDN, GraphCDN to point to your API, and that's literally it. You're off to get started and you're off to the races, and kind of my understanding is GraphCDN itself kind of does all the rest. GraphCDN itself, because it's handling essentially your mutation operations, it knows where you're making those mutations. It kind of knows the payload that you're expecting from it. It knows essentially what to make requests for onto your origin API. Is basically my understanding?
Yeah. There are some differentiations as well between what parts of the schema you're caching. So you're starting out with probably a baseline cache hit rate. It's hard to predict where you are because if you're a news site, few people are changing their data And if you're a social network, everyone is kind of changing your data. So there's some kind of degree. Max has just published a post about this, around this kind of quadrant of how many writers and readers there are in your data.
That's really interesting. So he just published a post on that. So I'll grab the link from you later, and we'll make sure that it's within the video, so other people can basically follow in on that. But I guess just for right now, like essentially, what is that quadrant? I assume kind of as you're saying, a newspaper is very read heavy, and so therefore it makes itself very susceptible or very it's a very natural caching. Like it's a very natural use of a cache for something that's very read heavy. But he says something like a social network is potentially read heavy, but also very write heavy, and also write heavy from multiple different sources. Like every user is writing, opposed to a newspaper where it's a bit more centrally published from the newspaper. Are those types of the quadrants that you're talking about, or?
Yeah, there are 4 quadrants because you're talking about many writers that change data, or if you have more readers that actually read that data. But then that same data also reaches a different audience. So you might have an audience that is pretty small. So maybe many people are writing just a few bits of data, but that data only goes to that small group of people. Or on the other hand, there are few of many writers and that data goes to almost everyone. So on a news site, there's also the difference of, well, you have few writers, but that content is going to many people, and that is where you get the biggest cache hit rate.
Interesting,
But
yeah.
if you have many writers and you have very small, tiny audiences, then you'll have a very low cache hit rate. And that's not a bad thing. It might average out. You just have a baseline. You set up some cache rules in GraphCDN to manipulate that and potentially make it better.
And I'm assuming GraphCDN probably tells you what your cache hit rate is.
Yeah.
And so like again, like it's so simple to set up. Set it up, go see if it's working well or not, and then and I assume that you can tweak and adapt to make it work better. And I assume that's kind of the next set of content you're publishing or have already published, just kind of around that area, which is more help and advice on kind of how to improve your caching. But amazing. Congratulations on all the great work and on running GraphCDN, I guess. I guess we'll transition now to other things you're involved with. So we mentioned Urkel. So can you tell us more about Urkel, why Urkel exists, kind of what you're looking to solve with Urkel, graph cache, like that type of stuff?
Yeah, with Urkel, there was a project started at Formidable Labs. It's a GraphQL client. And one might think these days, there's so many ways to call GraphQL APIs, all the way from just making the call yourself to using something like Relay or Apollo client. Why do we need another GraphQL client? Frankly, when we started, it was a different climate where not all options were explored. And specifically Relay and Apollo, while they were very proliferated and used a lot, were not exploring a lot of the options that are available. So on a lot of sides, we wanted to have a different set of trade-offs, and that's why we started Urkel, and that's we kind of experimented around with it, and we came up with different principles than what Relay operates under or what Apollo operate under. And the interesting thing is, if I look at it now, what we've kind of ended up with is also a client that is pretty agnostic to what you're doing and how you're doing things. If we look at Relay, it's obviously very targeted towards React. Apollo client less so, but it's still their bread and butter. It's still very much catering towards React. And naturally, we moved a bit further away from that. And that's kind of where we also started getting some community help on bindings to different frameworks. But the interesting thing was we just started from scratch. We didn't look at what the others were doing too much and just wanted to see where we end up.
Yeah, interesting. And I remember following your journey because obviously I've met Phil. He's one of the first guys I met in London. I met you probably 5 years ago. I don't even know where we met or how we met or why we met, but we met, and and so here we are. And so like essentially I ended up following the journey of Urkel and the journey of Phil. And I remember there were kind of a few things that you were experimenting with around the time that you started, I guess, rewriting Urkel for V2, which was I think it was callbags. And so you did a lot of work using, I think, ReasonML callback implementation using a library called Wonka is what you created.
Yeah.
And so I guess tell me more about that.
Well, we realized that GraphQL is very much a stream-based protocol, even for queries, because you're always sending updates. So we knew from the start that whenever you're dealing with caching, you're essentially not saying, hey, I want an update, but you have a different operation running. That operation tells you this data has changed and you get some new data. So when you're dealing with GraphQL, because it's always changing things across your app, changing things across queries, you'll probably have to listen to many updates. What we also realized is, well, we want this thing to be extendable. We want like the cache to be swapped out. We want everything to be kind of customizable. And that kind of ties in with streams as well, because you have a stream of incoming operations and you have a stream of outgoing results. So what kind of transpired was, well, we want to do this, but it doesn't really matter what streaming library we use. And the main priority was, this is a really heavy feature. This is really like logic that can get out of hand. We wanted it to be small. And around the same time, Andre Stoltz worked on the callback proposal, which was a spec of the tiniest stream/observable library you can imagine. And that really enabled us to build something that was small enough to not buy into that trade-off of, we want this complex streaming logic, but we don't want to pull in too much code.
Interesting. So it was a kind of less is more. Callbags as a concept allowed you to build kind of that kind of two-way streaming. We're not talking about hot tub streaming. That was earlier in the conversation. That's a different type of stream that's very heavy. We're talking about lightweight callback streaming here, okay? But basically, my understanding is it's a stream from your client to your server. That's kind of one direction, and then it's another stream from your server back to your client. That's kind of another direction. And so really, it's processing the data on both of those streams, going into your server and coming back out to your client, which is basically the core of Urkel, and it's basically the core of what makes everything work inside Urkel. And that core is built on kind of what you're saying, like Andre Stoltz's callbag specification, but your implementation in Wonka, obviously, which is what Urkel uses. And Wonka is written in Reason, right?
That's right. Yeah.
Yeah.
Which was just, I think that was just because I liked Reason at the time. The interesting thing about that concept is also, as you're saying, you have these operations going to the server and then back. It's almost like train tracks. Because you have trains traveling to your API and then coming back. But if you look at it from a passenger's point of view, you're on that train, you have a specific target, you have a specific goal, and then eventually you will return. And that's like your individual operation, right?
Interesting.
But then if you imagine how we thought about extensions, it's like stops on that track towards your server. As a passenger, you can get off at any of these stops. As a passenger, you might not be going for that final destination, which is where caching comes in. But these different stops change how these trains travel towards that destination.
Well, that's super interesting. That's such a cool. I love that analogy so much. In fact, I'm going to steal it.
You're going to steal it
as my own.
Okay.
This train stops here. But that's such a cool analogy. So basically, if like to use that back in the context of GraphQL, like if you have an operation starting from your client, you're hopping on the train from your client, you're going to the first stop, which is maybe adding authentication information or whatever it is.
Yeah.
And then I guess you get a jacket on your passenger or whatever it is to kind of show that they're authenticated now. They go off to the next stop, which is basically like the caching layer, the caching stop. And so they kind of say, hey, like, do we know who you are? Or do you got to go for further questioning further on down the train? And so you can either get off there because they know who you are. You basically hit the cache, and you can get cache results back. You can get off at that stop, wait for the train going the other way, and kind of go back to the client. Or you keep going, I guess, further to the server. You got your authenticated jacket on. You make your way to that final destination, the server. Not like the movies, not like the movies. And then you kind of get your whatever you want. Maybe your bagels and your coffee from that destination. You hop on the train coming back, and then when you're coming back, you stop off at the cache again, and you say, "Hey, cache, got my bagels, got my coffee."
Bagels, yeah.
I got my jacket on still, and then you can go right back to the front end, which is where you started from, and you kind of get all the things that you want. So that's actually such a cool analogy that I felt like I kind of overkilled that analogy there.
Well, the interesting thing is that in the context of GraphQL, where the analogy breaks down, it's almost as if while you're traveling on this train, no time passes and time stands still, right? But as soon as you go to the server, that is when you're kind of waiting. I don't know, maybe at your destination you have to wait for your bagel. But the interesting thing that transpired was, at least when you're dealing with extensions, you kind of ignore what happens on the train tracks themselves. And so in the front end, you can differentiate, hey, this just came back. This person has basically never left the train, and I can immediately just put them there in their final destination. Or, hey, I'm still waiting for this person to come back. They're probably waiting for their bagel. So this is where the analogy breaks down. But the interesting thing about streams is the other advantage was you can easily differentiate whether something came from the cache or not, by whether you got the result instantaneously or not.
Interesting, very interesting. I love that analogy so much. I think if I'm not mistaken, like that kind of two-way stream or kind of two-way train tracks is there for no matter what type of cache you have on Urkel. Because I believe there's a few different types of caches available. One of them is graph cache, and then one of them is a document cache. And kind of that kind of streaming layer, it's there for both. It's kind of the underlying kind of architecture of Urkel that everything else is built on. And so that enables you to become modular with things like caching, enables you to become modular with things like the actual transport mechanism, like to that final destination. Allows you to become modular with like how you want to write like authorization headers and so on and so forth. Someone's at my door right now, but we're going to ignore them because they're just going to drop off something and then they're just going to be fine. So my understanding is because of that because of the modularity there, it enables you to kind of slot in these stops in whatever type of configuration you want, including things such as a whole different caching layer, which basically I don't think anyone else can really do. I think like every other client out there is very particular about their stops, or very particular about their normalized cache.
That's right.
Caching
yeah.
layer.
It depends on whether you see all of these stops as the same thing or different, right? Whether you treat caching as this special thing that you have to treat differently in your client or not. It puts certain constraints on what we can do with the cache, and we have to think carefully about what we want to do in the future. For now, it's served us well. But yes, we have 2 cache implementations, and we've seen people customize the document cache. There's probably a sliding scale where people can, pick and match things that they need, which people often don't do. As it turns out, most customizations are not done by people writing their own, but by people just picking up what we already have. But that's where the time-saving aspect comes in. To an extent, you can write all of this your own, and as soon as you have to write some of it, people are looking at, how can I save time here?
Yeah, that makes sense. I guess we won't go into the depths of the 2 different types of caches, but I guess at a very high level, like essentially one's a document cache, which caches on a per operation basis, is my understanding. And so for each type of query that you have, or each type of mutation that you have, that's an operation. It kind of caches on a per operation basis. And so my understanding is that it looks at each operation, gathers the types, like literally, like if you have a user, if you have a place, if you have an event, whatever the GraphQL types are. When you see a mutation that happens with the same type, you just clear out all the queries. Is that kind of how it works?
That's right. Yeah, okay. That's the easiest way to ensure that everything refreshes, but not quite every single time. So essentially, it's the best way to get started because people don't have to think about their state. The only thing they then have to worry about is, displaying a loading spinner well, which is still fine. And GraphCDN is actually kind of in between the two, because GraphCDN does that kind of quote-unquote aggressive invalidation, but on keys specifically, so it takes more data into account.
Yeah.
And then a normalized cache obviously is a bit of a different trade-off because you store more and invalidate almost never.
So essentially for me, like I'm using a normalized cache. I really like a normalized cache. It works well for me. But if your server and your client aren't structured in a manner that can leverage a normalized cache properly, I think what you said just now was really interesting, where you could actually use a document cache. You could that's perfectly fine to use. It will result in a consistent front end, a few more loading spinners, but GraphCDN can kind of slot in very nicely, especially with that model, where GraphCDN can actually take on a lot of the caching burden of your application. So even though you are actually hitting the server and refreshing more frequently than you might want to, having GraphCDN in place means that you aren't actually going all the way to your final destination. It's kind of like adding another stop where it just hits that stop and kind of comes back instead of going all the way to the end, which potentially takes a lot of time. So I think that was actually very interesting there. Yeah.
Right. Yeah. The idea is you can still cheaply cache and be a bit more loose around it, because the worst case becomes less and less likely. And even if you hit the worst case, I mean, hopefully your API is not super slow, but even if it is, and you'll just change the caching on GraphCDN to make it less likely that you're still going to make a user wait multiple seconds.
Hey, now I told you, my API is fast. It's Salesforce that's slow, okay? Okay, that's super interesting. I guess the other thing that I know that you're involved in is style components, of course. I know you were involved in style components way back in the day. That's how I first met him. Actually, like I remember how I met you. I met you because Ken Wheeler shot a crossbow at you on stage.
That's right.
Yeah.
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 And I'm still here.
Yeah. Wow.
It was a JavaScript controlled crossbow. So it was for science.
He's either a great actor or he's lying. I don't know which one. Because like if someone shoots me with a crossbow, I don't think I'll last very long. So
I'm acting. I'm actually dead. Crossbow hit me, killed me. That was the end of it.
He's an animated corpse, everyone. This explains a lot. But no, style components. And so I think you're working on style components back then, weren't you? Yeah.
Yeah, back then. It is considerably slowed down since then, mostly because I think it's interesting because we chose certain constraints that still make it good and that still made it good at the time. And those are the ones that really resonated with folks as well that like CSS / we don't have to always differentiate between people like to have their CSS and JS.
Essentially, for me, I hate CSS. I hate it. I hate it with a passion. No, I'm just kidding.
You just do JS.
I love Oliver Turner, but I hate CSS, and so I feel like the two are basically at odds with each other, which makes me love CSS because I love Oliver Turner. So we'll have to get Oliver Turner on here another time. So you've been called out now, Oliver. But sorry, I kind of took away from the core purpose there of style components. So
no, that's completely fine because Oliver has also made good points around that it depends on what parts of CSS you embrace.
Interesting.
Like embracing the cascade and choosing the right constraints to impose on yourself and imposing onto the users of style components. And I find that if anyone's wondering why it slowed down so considerably, the constraints we chose made it good at a time and still make it good for your average use case, as it would have been 2 years ago. But it's kind of reached a point where we would have to drop these constraints to actually move forward. And then it would become a Frankenstein style components just being style components in its name, but not in its spirit.
And when you say slow down, you don't mean you mean in terms of performance, or do you mean in terms of you mean your contribution to it? You mean your
in terms of contributions and releases? Yeah,
in terms of release cadence.
Yeah.
Okay, but in terms of performance, it's probably faster than ever right now.
Yeah, it's still as fast as it was. One of our goals was just to make it faster over time, and I think we've reached that. There were some interesting challenges, and there still are some challenges that are unsolved, obviously, because not everyone has this on their radar. Certainly, the Chrome team and Firefox, Mozilla teams, aren't interested in making this faster because the favored constraints have changed a bit. And the favored constraints have moved more towards making sure that you can generate more of this upfront, which is still fine. It's just around CSS didn't have the capability sometimes to do the things that we wanted to do, and now it does.
Interesting. Very interesting. So we just spoke with essentially Siddharth back in Amsterdam, and he's of course very big into the design system space and very big into trying to find creative ways to enable teams to obviously scale design across an organization. Yeah. In my experience, style components has been a critical piece of that puzzle. But it sounds like if I'm kind of understanding what you're saying, there were some constraints that were made earlier on that are now making it kind of at odds with things like extraction. Is that kind of what you're talking about, CSS extraction, or are you talking about something else?
That's part of it. Okay. There's just a lot of small kind of paths you can take that either make style components the best version of itself that it can be, or make style components the thing that can evolve into the better library.
So what you need is like a two-way train track type of thing.
Two-way train track kind of thing. You need to be able to go to your destination, but also come back because actually you want to get off at a different stop.
Basically, it's GraphCDN, but for CSS, everyone. That's what they've been working on. That's what all the hot tubs are about.
That is what we're announcing. CSS CDN.
CSS CDN.
Yes.
There you go. That's what the hot tubs were about all along. Awesome. I got it out of them eventually. We didn't have to go into the basement. We're good. But okay, so like essentially like what do you mean though? Like it's very abstract to me.
Right. So I like to basically point at different libraries. If you're talking about just basically styling and how it's evolved from CSS modules, you could look at vanilla extract. Vanilla Extract is interesting because it uses TypeScript instead of what Sass used to be or less used to be. So you're compiling basically separate TS files, css.ts files, to your styles themselves. And you basically just use that. So it's a combination of CSS modules, but written in TypeScript. So basically you get a bit more flexibility. And we've seen Linaria, which does the static extraction bit and has a set of different constraints altogether that you need to respect. And then it's interesting, what I find the most exciting is Stitches right now, because Stitches constraints enable them to basically move forward much quicker than the other libraries. Because basically they found, well, if we just start from scratch and we think about this as there are only so many combinations of styles you can generate, then you can basically generate them up front. You don't have to create them all up front, but if you can create one rule for every variant and you basically in code have something that is statically analyzable, then you can do things like reduce the cost because you're never doing a lot of dynamic things. You're just basically creating something.
Interesting.
The only differentiation becomes then when you're creating those styles, but it doesn't really matter because the end result's the same. So I think they have a better chance at kind of coming up with new approaches.
Is that what you're using now, Stitches, or?
That is what we'll be using, or that's what I'd recommend personally as well right now.
Very interesting. Very interesting.
Very spicy.
So, very spicy there. So Phil Pluckthun, the one of the core maintainers of style components, does not recommend style components. I'm going to tell everyone now.
You can still use it. It's still great for the constraints it does. But if you're building a design system, there are better things out there.
Interesting. Well, you heard it from Phil himself. Yes. Now I will never be. No, like I haven't been using style components for years. I'm honest with you. I haven't been using it for years.
For years.
I haven't been using styled components for 3 years. Yeah, yeah. And I don't mean I've switched to Emotion or something like that. I don't mean I've literally been using the same thing just in a different library. No, I haven't been using that style of authoring CSS for about 3 years now. Like essentially not because it's right or wrong. Like I really enjoyed using style components, especially on React Native before, where I really disliked using the native style sheet.create implementation. Style components on React Native to me just made much more sense. But more recently, over the past 3 years or so, I've been using more of more of a design system variant style of styling, where my styles are all held very centrally, and then I use a variant to kind of refer to what component and variant of that component I want, but all of that stored very centrally. It's not stored on a kind of per component level. So hence, I just haven't been using style components for a while. So yeah.
Oh, that's fine.
Yeah, yeah. That's why I bought him a bagel.
Well, the hot new things are design tokens as well, right?
Design tokens, yeah. Essentially our variants are composite tokens. And so a variant is just a collection of tokens, and then we have like base tokens, and then we have kind of a variant of those tokens. And so it's really a combination of those two things. But yeah, from a design system perspective, and again, for what's worth, I stole all this from Siddharth, by the way. So really what I do is I just steal good ideas and I kind of pass them off as my own. So I'll be using the train tracks from Phil and then the design system from Siddharth. But basically, yeah, like the advantage there was that because we aren't styling on a per component level, because we're styling more centrally, it's easier for us to roll out and manage styles as they adapt. And so, yeah, that's basically it.
No, that's basically it, right? And I still remember years ago, Adam Morse already gave a talk on this where he was saying design tokens are kind of dimensions, and every time you create this dimension, you narrow down your options. And it's so funny seeing that play out most clearly in Stitches, because you have your design tokens. Obviously, it's not just Stitches, but if you have your design tokens and you create all of your variants, you're narrowing down all of your possible components to just a few options.
Interesting.
And this narrowing down is a lot easier to manage than something like style components or Emotion, where you're building up things from zero, right? And you're creating more options over time.
That's again a very good way to put it. That makes a lot of sense to me. Well, cool. I guess the last thing that I'm curious about, so we talked a lot about GraphQL performance. We talked a little bit about how style components is quite performant and is quite fast now. I know you were involved with some of that work in I guess in the earlier days. I think V2, V3 was maybe where you were more involved in style components. I forget. And now obviously with Urkel as well, especially working with Yovi, who's kind of obsessed with performance and bundle size. Yovi will bundle size shame you. I love Yovi, but he will bundle size. He's bundle size shamed me. I told him, Yovi, it's not the size of the bundle. It's how you deliver it that matters. Yeah. Yeah. No, and
Fast.
So fast. I deliver it quickly. And so, like a big criticism of GraphQL on the client is basically a lot of these GraphQL clients pull in all of GraphQL JS. I know you worked on a solution to that. Can you tell us more about your solution?
Right. It's an interesting kind of argument to be made, and I've seen that several times, that GraphQL inherently means that you have a big client, which obviously doesn't have to be true. You can circumvent all of this and have no kind of part of GraphQL on the client side and just send your strings. The thing is, the tooling just won't be as great. That's just the reality of it. You can compile ahead of time. Technically, that means you're still using it. You're still using GraphQL JS, the reference implementation, unless you're implementing it in a different language. Doesn't matter. The thing is just that it's inherently a technical problem. How can we make this smaller? GraphQL JS has been built for mainly a reference implementation and backend use case. So the only thing to solve that with is, well, why don't we just replace parts? So I have experimented with shrinking down the parts that are used by libraries like Apollo Client and Urkel by just swapping out the larger parts of GraphQL JS. So it's as simple as sometimes just saying you alias it. So I have a package on NPM called GraphQL Web Lite, which is that experiment. You alias to that, and you basically get the same thing, but you'll just shed some weight of GraphQL JS.
And by shed weight, he means quite a bit of weight.
Quite a bit.
In fact, quite a bit of weight. And so my understanding of how you achieved that was basically you kind of split out all the different parts of GraphQL into separate files. And then what, did you also write a Babel plugin to help like know what to import, or am I imagining that?
It's just based on rollup. So
just based on rollup.
It just rebundles it. It looks at every single dependent file. What that allowed me to do was, I basically looked at what are the most expensive files. Which one of these are actually used on the client side? Which parts can just be thrown out? A lot of things are just utilities that are pretty much not relevant in that case, because as you throw one thing out, it might depend on another thing you can throw out. There are things like debug output. So when you're basically string finding things like the GraphQL errors that you don't really need in production, things like that. The biggest thing I think was just the set of trade-offs, because are you optimizing for absolute maximum performance, which is nice for the GraphQL API, where you don't care about how long it takes to deliver the code, because the code is there and running, but instead optimize for size and trading off a bit of performance. So things like the visitor can be much smaller, things like the parser can be much smaller, and they'll be maybe half the speed-ish. At that point on the client side, you don't really care about that. When you're running things once or twice, it doesn't make a difference.
Yeah, it's not like you're executing a GraphQL. It's not like you're parsing GraphQL at like 10,000 times a second on the client.
Exactly.
If you are, I have to ask why. Why are you doing that?
Well, I have heard of people who are loading actual DNA molecule data via a GraphQL API into a frontend that visualizes that.
It's a good thing DNA is small. You know what I mean? Like DNA is, it's just like 1 or 2 bits of data. It's not really a whole lot.
In terms of bundle size, it's doing great. It's very compressed. In terms of how your browser handles that, apparently poorly. Oh well.
Well, I mean, should you be loading entire strands of DNA information into your client? It's another question.
I never heard about it again. It would be quite interesting to know what was being visualized. Do you need to? Probably not. Why are you loading it from GraphQL API? I don't know.
I mean, why not? To be fair,
not?
I mean, why not? I mean, like previously, we consulted at a very large IoT company. And I think that's a great example of like whatever can be GraphQL better be GraphQL because essentially when you have all these IoT devices, they have so many sensors on them, they have so much data like within them, and basically what they do is they just take their entire memory state and just kind of dump that onto a server. That server is then in charge of doing all of the stream processing to kind of take out the relevant bits of that data and then pass it off to a front end that's meant to represent something with it. And so really, it really reminds me of kind of the train tracks that you're talking about there once again, which is that you kind of have a train track starting from the device, ending up at your like on your phone or whatever. at the end of the day, GraphQL still is the best way of kind of displaying that information. GraphQL still is the best way of selecting what parts of that you need, which again tends to matter when it comes to stream processing, because then you can only process the parts of the payload that you actually want, which is another kind of optimization that can be made there. But at the end of the day, essentially what I was getting at was these GraphQL types were just massive. Because you can imagine just an entire dump of a memory state on a device could be quite large. But GraphQL still made sense, even though the payload size would potentially be quite large. I imagine it's probably something more similar like for DNA use cases where like it is quite a large payload. It is potentially quite a large JSON blob. But I think being able to define a schema for that and define kind of where the data lives still helps you kind of essentially decouple teams in a way where one team is more aware of what data they have like on catalog, and the other team is more aware of what they can consume for whatever experience they want to build. So I guess it works, but it's definitely one of the more extreme use cases that I've heard of.
Very extreme, but no, that it kind of has proven to me that GraphQL is not about these kind of technical constraints, because it decouples these technical constraints and how you are using GraphQL from why you're using GraphQL, which is more around the team aspect, which is more around, well, I want one language to talk between my backend team, my frontend team, and as an organization, and then utilize that language completely separately when you're actually talking about how you implement it.
I couldn't have said it better myself. And so I guess that's kind of Phil in a nutshell. So I think the things that I know Phil spends a lot of time on is he spends a lot of time experimenting. He spends a lot of time coming up with these wild, crazy ideas for things, such as, hey, what if we write callbacks in ReasonML and then like make GraphQL lighter on the client? And I think you've had some other crazy ideas like JSON parsing like efficiencies and
JSON parsing efficiencies, yes,
and like a bunch of other crazy ideas out there where I'm like, dude, like have you heard of this thing called grass? There's some grass outside there. Like you should try touching it from time to time.
Sometimes I touch it while writing code. It's great.
He has grass indoors now. Lovely guy. And so he kind of works on these kind of crazy ideas that ends up actually being brilliant. And I would highly recommend go follow him, checking out his work, and potentially using GraphCDN. They know how to make your APIs fast, and so may as well make them fast. Well, yeah. Thanks again, Phil.
Thank you.
I'll do one of these handshakes.
Do one of the very firm handshakes.
Indeed.
Oh, that's too firm. Good handshake.
I've been holding my gimbal this whole time, of course. Well, yeah, we'll see you next time. Thanks. Bye now.